Alright, so this is Mike and Toma. We are in a car, and we are doing the Newton experiment with the helium balloon. And our hypothesis is that the balloon would tend to do what a body would do, so that is, if we accelerate, our body, or the balloon, would tend to go backwards.
Because objects at rest tend to stay at rest.
Yes. So, and if we accelerate, the balloon would go back. If we'd brake, the balloon would go forward. If we turn left, the balloon would tend to go right, and if we go right, the balloon would tend to go left because of Newton's first law, which is an object at constant velocity would tend to go at constant velocity unless changed by an outside force. So, we will see what happens. We are going to go down Thatcher in a second. Alright, here's our balloon. Alright, and now, right now, we're at constant velocity.
Notice that the windows are not all the way rolled down, so there won't be an outside wind force that could play a factor.
Alright, so right now, we just made a right turn, and the balloon went to the right, which was weird. Alright. Now what's gonna go on? Mike's gonna floor it, and the balloon is going back right now. If he applies the brakes right now, he's accelerating right now, the balloon is going back. Alright. Now if he applies the brakes, the balloon is going forward. Brakes, balloon's forward. Alright. Right now we are going to make a right turn and see what happens to the balloon. The balloon went to the right instead of our hypothesis saying that the balloon would go left on a right turn. So that's kind of weird. Alright, so right now at the stop sign we're going to make a left turn and see what happens. There's that stop sign over there. There's the balloon. Alright. This turn we're going left, and the balloon is going left with Mike instead of it going right on a left turn. Now the question is, why is the balloon doing the opposite of what we thought? And after we saw the video, the guy said that since the heavy air in the car, when it wants to stay at constant velocity, so when we apply the brakes, the air would tend to go to the front of the car. So the balloon, since it's lighter than the air, will go to the back of the car. A very nice car that we drove by.
So now what's going to happen is we're going to be accelerating in our car, and we're going to see what the balloon does. Logically, the balloon should move backwards, but right now it's moving forwards, which is contradictory to our hypothesis. And when we brake, the balloon moves backwards, which should actually move forward. So this brings the question, why is the balloon acting like this? Most likely, it's because helium's lighter than air, so helium doesn't react the same way that air does.
For the analysis, what our balloon did, contrary to what our hypothesis was that it did exactly the opposite of our hypothesis. So when we accelerated, it went forward. When we braked, it went back. When we turned left, it also went left. And then when we turned right, the balloon went to the right.
The only possible explains that what could have happened that was not true were variances in looking at what we saw was happening with the balloon. The whole time our windows were rolled up, but mine wasn't rolled up all the way. Mine was rolled up like a quarter of the way because it's kind of hot outside. So there could have been air pushing against the balloon from the outside, and it could have resulted in a different direction of the balloon.
This guy's not moving at all, so people are honking, sorry. So yeah, for the final like analysis of our experiment was
that most likely because helium is lighter than air, that it does not react the same way as air does and human bodies do in a car.
And that's about it. And that's a wrap. I see San Diego.